The major categories of the expandable mold per mill pattern casting processes are the sand, the shelled mold, the plaster mold, the ceramic mold, and the vacuum casting. Casting metals in a sand molds is a traditional method and has been used for a millennia. Sand casting is still the most prevalent form of the casting. The typical application of sand casting include the machine bases, the large turbine impellers, the propellers, the plumbing fixtures, and the wide variety of the other products and components. Basically, sand casting consists of placing the pattern that having the same shape of the desired casting in the flask. Start adding the sand that already has been prepared earlier to both ends. The sand should be added with a sufficient amount to fill the whole cavity of the flask. Compacting the sand to add some rigidity to the green mold. Incorporating the gating system to allow the metal to flow within the cavity of the mold. Removing the pattern to create the mold cavity. Sometimes the goes are required to shape the part internally. Also, some chemical filters need to be added to remove the sludge material. Close both ends of the mold, and then the mold is ready to be filled with the molten metal. Fill the cavity with the molten metal and allowing metal to cool down until it's going to be solidified. Breaking the mold and take the part away. The whole sand casting process steps can be simply summarized in the following flowchart. Most of the sand casting operation using the silica sand as a mold material. The sand is inexpensive and is suitable as a mold material because of its high temperature characteristics and high melting point. There are two general types of the sand. We have the natural blonde, which is known as the bag sand, and the synthetic, which is known as the lake sand. Because of the compositions, this can be controlled for more accurately. The synthetic sand is preferred by most of the foundries. And for proper functioning, the mold sand must be clean and new. Several factors are important in the selection of the sand for molds, and certain trade-offs with respect to the properties are involved. Sand having fine, round grains can be packed closely and thus forms a smooth mold surface. Although the fine grained sands enhance the mold strength, the fine grains also lower the mold permeability. The permeability are required where the fluids and the gases penetrate through the pores. Good permeability of the molds and cores will allow the gases and the streams evolved during the casting to escape easily. The molds also should have a good collapsibility to allow the casting to shrink while cooling and thus to avoid defects in the casting, such as the hot treating and cracking. A typical foundry sand is a mixture of fresh and recycled sand, which contains 90% of the silica, 3% of water, and 7% clay, where the clay is going to be considered as a binders for the sand particles. The grain size and the grain shapes are very important as they define the surface quality of the casting, and they measure mold parameters such as strength and the permeability. The molds can be classified into several types. The most important one are the green sand molds, which is a mixture of sand, clay, and water. The dry sand molds with organic binders rather than the clay used to make the mold. And we have the skin dried mold, where the drying of the mold cavity surface of the green sand mold to a depth of 10 to 25 millimeters using the torch or heating lamps. Vacuum molding, also called the V process, was developed in Japan around 1970. It uses a sand mold held together by a vacuum pressure rather than by a chemical binders. Accordingly, the term of the vacuum is the process refers to the making of the mold rather than the casting of operation itself. Because no binders are used, the sand is readily recovered in the vacuum molding. Also, the sand does not require an extensive mechanical reconditioning operation that normally done when the binders are used in the molding sand. Since no water is mixed in the sand, the moisture-related defects are absent from the products. The disadvantage of this process is that it's relatively slow and not readily adaptable for automation. Because the mold is a thin wall shell of ceramic or sand, it's called the shell mold. Since a solid naphthalene is going to be used for preparing the molds, complicated shapes and a thin casting walls can be produced with this process. In this process, a mounted pattern is made of ferrous metal or aluminium is going to be first heated to the range of 175 to 370 degrees. Then it's going to be coated with a parting agent such as a silicone, followed by a clamp to a box or chamber. This box is contained a fine sand mixed with 2.5 to 4% of a thermosetting resin binder that coats the sand particles. Either the box is going to be rotated upside down or the sand mixture is going to be blown over the pattern, allowing to form a coating. The assembly then placed in an oven for a short period of time to complete the curing of the resin. Most of the shell molding machines, the oven consists of a metal box with gas-fired burners that swing over the shell mold to cure it. The shell hardens around the pattern and is then removed from the pattern using a built-in ejector pins. The two half shells are made in this manner are going to be bonded or clamped together to form the mold. They are going to be prepared to be filled with the molten metal. Fill with the molten metal, leave it to cool down and solidify, and then the mold is going to be broke up to get the cast material. Investment casting process, also called the lost wax process. The sequence involved in the investment casting is easy. The pattern is made of wax or a plastic such as the polystyrene, either by molding or rapid prototyping techniques. A number of the patterns can be joined together to make one mold, called a tree. A tree have a significant increasing of the production rate. The pattern is then dipped into a slurry refractory material such as a very fine silica and binders, including water, ethyl silicates, and acids. After this initial coating has dried, the pattern is going to be coated repeatedly to increase the thickness for a better strength. The term investment derives from the fact that the pattern is going to be invested or surrounded with the refractory material. The one-piece mold is dried in the air and heated to a temperature of 90 to 175 degrees. It's held in inverted position for a few hours to melt the wax out. The mold is going to be then fired to 650 degrees to 1050 degrees for about 4 hours to drive off the water or the crystallizations and burnt off away a residual wax. After the metal has been poured and has been solidified, the mold is broken up and the casting is removed. Lost form casting, also known as the lost pattern process, or evaporative form process, or the full molded process, and the expanded polystyrene process. The mold in this process is made from sand packed around a pattern made of polystyrene foam. The foam pattern evaporates. The polystyrene foam pattern includes the spurs, the eraser, the gating system, and the internal cores if needed. The mold does not have to be opened into a cup and drag sections. In the evaporative pattern casting process, the pattern is going to be made from the polystyrene, which evaporate after the contact with the molten metals to form the cavity for the casting. The polystyrene pattern is formed with the use of the metal mold methods and then is going to be supported with refractory material, packed within the flask with the sand to support it, and upon the contact with the pouring molten metal, the polystyrene will evaporate and the cavity will be filled with the molten metal that will be slowly cooled down and solidify. In the plaster molding process, the mold is made of plaster of Paris, which is known as the gypsum or the calcium sulfate, with the addition of the till and the silica flow to improve the strength and control of the time required for the plaster to set. After the plaster set, usually within 15 minutes, it's going to be removed and the mold is going to be dried at a temperature range of 120 to 260 degrees. High drying temperature may be used depending on the type of the plaster, and the mold house are going to be then assembled to form the mold cavity and going to be preheated to about 120 degrees. The molten metal then is going to be poured into the mold. The ceramic mold casting process, that also known as the cope and the drag investment casting, is similar to the plaster mold casting, except that it uses refractory mold materials suitable for the high temperature application. The main advantages of the ceramic mold casting are: first, the ceramic mold casting is advantageous for manufacturing of the components having thin sections. Also, accurate dimensions can be obtained by using this process. As the components have a good accuracy, the machining process is going to be minimized. Also, a smooth surfaces finishing can be obtained by the ceramic molding processes. It's also capable of make a components with weighing up to 700 kilograms by using the ceramic mold casting. Slurry is a mixture of fine-grained zircon, aluminum oxide, and infused silica, which are mixed with bonding agents and poured over the pattern, which has been placed in a flask. Pattern may be made of wood or metal, and after the setting, the mold are removed, dried, ignited to burn off the volatile material, and baked, and the mold are going to be clamped firmly and used as all ceramic molds.